Have you ever squeezed a water balloon and noticed how the entire balloon bulges, not just where you're squeezing? Or perhaps you've contemplated why a hefty ship can float while a small pebble sinks? These are the physics phenomena we'll unwrap today. Pascal's law, Archimedes Principle, the concept of density and relative density, and the laws of flotation. First, let's dive into Pascal's law. Picture a water-filled balloon. When you apply pressure at one point, it gets transmitted equally throughout the water in all directions. This phenomenon, where any change in pressure at one point in a confined fluid is transmitted equally to all parts, is known as Pascal's law. This principle is at play in hydraulic lifts and brakes and deep-sea submarines. Now, let's move on to a principle that's all about balance. Archimedes Principle. This explains why objects float or sink. When an object displaces water, the upward force exerted by the displaced water, the buoyant force, opposes the object's weight. If the buoyant force equals the object's weight, it floats. If it's less than the object's weight, it sinks. Remember, the buoyant force is all about the volume of displaced water, not the object's weight. Next, we'll explore the concept of density and relative density. Density is like packing oranges in a box. The more oranges you pack in the same box, the higher the density. It is calculated as mass divided by volume. Relative density, on the other hand, is comparing an object's density to the density of water. Now, with these concepts in mind, we can understand the laws of flotation, which summarize an object's density and its behavior in a fluid. An object will float if its average density is less than the fluid's density. The deeper an object is submerged, the greater the buoyant force acting on it. An object floats at a certain level when the buoyant force equals its weight. Finally, we'll touch on a tool that puts all these principles into practice: the hydrometer. It measures the density or relative density of a liquid by floating in it. The depth it sinks reveals the liquid's density. It's used to assess alcohol content in beverages, battery acid strength, and saltwater concentration. So, there you have it, a simple breakdown of some fundamental physics principles. Remember, Pascal's law is all about pressure transmission. Archimedes' principle deals with buoyancy, and density involves mass and volume. And these principles all come together in the laws of flotation and the operation of a hydrometer. Who knew physics could be so practical?